Hey, Sam from 3D here. In this video on our playlist of basics of Blender and CGI, I will explain the basics of PBR materials. This video is a bit different. I'll focus on the theory instead of the practice, because if you understand the theory, you can go much further than just messing with a couple of properties without knowing what they actually do. And the material consists of multiple textures that when combined results in a single material. The PBR workflow is the most commonly used workflow in the 3D industry right now, be it in games, movies, or these awesome stylized characters that you can get at characters.design. PBR dictates how a material should behave in 3D scene, its color, how rough it is, if it emits light, if it's metallic, and so on. That's all handy dandy. But what does PBR stands for? It stands for physically based rendering. Basically speaking, it calculates a digital scene using math from real world light behavior. That means that your 3D scene is calculated like a real place in the real world. This gives us a very true to life visual, and we can still tweak it for artistic freedom. This is how we get visuals like this cool realistic art that look realistic. Yet this place could never exist. Alright, enough chit chat and let's see this in action. By the way, you can get these hands for free in description below. The material on this ball has all the properties we'll need to show this. I'll show you the main slots you'll be dealing with. This is the principal shader node on Blender. It's the main PBR shader used in Blender. I'll show you how to use nodes in another video. For now, let me explain the theory. The first slot is base color. As the name implies, it's color of the material. If you plug an image texture here, the material will have that color. If we just set a color and nothing else, the material will look like a printed piece of paper. It has no detail to it, everything is super smooth. This is purely color data, no reflections, nothing. This texture is also called albedo or diffuse. There are differences, but practically they work in the same way. Next one is subsurface scattering, often abbreviated to SSS. This dictates if the material absorbs some light, allow it to scatter before being released. Ever pointed a flashlight in your hand and saw that red light? It's SSS. It's mainly used in skin, candles, and some types of food, like grapes and ice cream. Metallic, it's a black and white value. It determines if something is made out of metal or not. In the real world, nothing is half metallic. So if you want realism, keep this to either 1 or 0. You can see the metallic texture for this material. It's fully black and white. Black is non-metallic. White is fully metallic. Roughness, another black and white value. It determines how well rough a surface is. Nothing in the real world is perfectly smooth. The closest thing is a mirror. In the same way, nothing in the real world is perfectly rough. Everything has some shine to it. Yes, even a concrete brick. Black is shiny and white is rough. Transmission. Put this to 1 if your material is made out of glass or jelly, anything like that. Transmission roughness is the same as the other one, but specific for this property. Emission determines if something emits light. Emission strength controls how strong that emission is. This can be colorful map as well. Alpha, same as any 2D application. It's used to make something transparent. Normal, this is a very intricate texture slot. See this in colorful map? It's telling Blender where to shine and not to shine light based on X, Y, Z coordinates. That's why it's colorful. Each color represents an axis. This is used to fake the detail. It's easier if I turn off for you to see. It's an easy way to add detail without the computer power cost. There is also a bump map. It does the same thing the normal map does, but it's easier to create. A bump map is black and white. Black gives the impression of push down, white gives the impression it's being pulled up. Gray is nature, nothing changes. Since it's black and white, you can manually paint these if you want to. But normal maps need to be extracted from high resolution model with the process called baking. That's pretty much it. In the next video, we'll see this in action with nodes in Blender. If you want more content like this, check out 3D.design. Thank you for watching. If you have a tutorial request, add them to the comment section down below. Hit the like and subscribe button, and I'll see you in the next video. And stay creative. Bye.